Welcome everyone. Our today's space talk is about becoming a citizen scientist. This space talk is organized group, and the speaker for today's session is Julien. Without further ado, I would request Julien to start with today's session.
Hello, everyone, and thanks for joining. My name is Julien de Lambilly. I live in Switzerland, in Lausanne. I'm 41 years old, and I'm a citizen scientist and passionate about astronomy for a very long time. So I will speak about my journey in astronomy and a bit about citizen science at Unistellar, as well as Planet Patrol and our next Zooniverse campaign. And I will introduce you to a tool I developed, which is called the Fast Light Curve Inspector, FLI. And I am open to question. If you want, you can ask a question or stop me. I don't know how it is planned, but we will have time to discuss together, and I will show you some picture as well. And okay, let's start. Um, so I'm really excited to share with you my journey into the world of astronomy, which began as a childhood fascination. It all started when I received my first book about the solar system. Um, I was amazed to learn that there were other worlds beyond our Earth floating in the sky. I was, I don't know, 7 years old, I think. And this curiosity turned into an obsession. And I absorbed every piece of information I could find about space and stars and the solar system. I remember. And in 1995, well, something incredible happened. I heard the news that scientists had discovered the first exoplanet ever. And I remember feeling stunned, and my heart raced with excitement. And for days, it was all I could think about. And the universe seemed, so full of possibilities and making me wonder of what else it is out there, and could we really be alone? I think we're not alone. And soon after, um, I think I was 12 years old. My parents gifted me with my first telescope, small 10 centimeter. And I'll never forget the first time I gazed at Saturn and its magnificent rings, and Jupiter and its moons, and for you who've experienced this, you know exactly what that awe-inspiring feeling is. It's really something you remember all your life, I think. The first time you see those planets in a telescope. And then over the years, I continued to observe the stars whenever I could. And eventually, I was able to buy a bigger telescope. I was maybe like 22, 23 years old by the time. And I would travel to top mountains, to the mountain tops, and sometimes, lying in the grass or even on the snow, just to chase galaxies and watch the stars. And each of these moments reinforced my passion and led me to where I am today as a citizen scientist, making my own contribution to the field of astronomy. And I'm really doing something that I think everyone can achieve. Despite my deep passion for the night sky at the time, sharing this fascination wasn't always easy. You can picture trying to convince people to join me for a night of observation at the top of a mountain, or maybe in the summer it was okay, but very late. But in the winter, with temperatures dipping to minus 15 degrees or even lower, I was alone. And for about a decade, I often felt alone in my passion, and I wanted to share those awe-inspiring moments with others, but I didn't know how to reach them very well. Although I just telling them, "Oh, yesterday I saw this and I saw it, and it was marvelous." And this challenge led me to think about, bringing the stars to the people instead of the other way around. And it was just the dawn of the electronically assisted astronomy. It's a perfect blend of live observing and astrophotography. And I built a rig with a camera that took short exposure pictures and a computer to stack these images, accumulating lights over time to reveal stunning images of galaxies and nebulas. And while setting up my 80-kilogram rigs took nearly an hour, yes, the results were already mesmerizing. Yes, I will present Fly Inspector next, and the Eclipsing Binary Patrol next, but not right now, of course. And then I think my journey took a significant turn when I encountered Unistellar. It was many, many years ago, maybe 10 years ago now. I read about their innovative telescope prototype, which embodied the very technology I had been using, even more, but the same that the one I was using, but in a plug and play format. And I knew I wanted this telescope the day it would come out. And I was able to secure one of the first units through the Kickstarter campaign. And I finally, few years later, I received my Eviscope in March 2020. And it was right at the start of the COVID-19 pandemic. And with fewer work commitments and the freedom to travel within my country, we were really lucky. I spent countless nights in the mountains, observing the stars, or in my garden or outside of the city. And this was this period that I learned about efforts made to detect exoplanets using the Eviscope. And I was really eager to get involved. And so I reached out to the community, and in particular with Dan Peluso, that guided me along with a connection to Tom Esposito and Frank Machis and Joey Asensio, and another, of course. And after several attempts, I spent one night focused on a single star from my backyard here in Lausanne. And upon sending my observation to the Unistellar team, I received the confirmation. So I had detected the exoplanet Qatar 1b. And that moment of this career was very exhilarating. As when I first heard about the discovery of the first exoplanets back in 1995. I was very, very happy of it. And I had detected another world, from my own backyard. And this was a really incredible achievement for me. I didn't know I could do this with my rig from my garden, and it was really amazing. I can show you just the. Let me share, present. Okay. Just as a proof, this is what I got back when I uploaded my observation data, and they sent me this, and you can see that's here that's a light curve representing the light of the star Qatar 1, and we see that the light is dipping here, meaning there is the planets passing in front of the stars relative to us. And so this is the proof. I really observed it, which was really a great moment for me. Thanks, Mario. Yeah, we have some unistellar stuff and friends here. Thank you for joining as well. And it was 4 years ago, and my involvement with unistellar deepens as I began to test, the full capabilities of the EV scope, and for various scientific purposes, including, of course, exoplanet transit observation, asteroid tracking, planetary difference initiatives. And I know today we can observe like supernovas, satellites. They have a lot of citizen science campaign running every month with new targets. And these sessions were very thrilling at the start because nothing was automatized. We were all discovering how to do it. And I was often live connected with the Unistellar team and following their precise instructions on where to point the telescope and exactly when to observe. I remember a few times where Frank Matches were texting me, "Oh, are you available in 40 minutes? There is an asteroid we would like to observe." And I was, okay, yes, let's go. I took the telescope in the back with my car out of the city, and I had to install it very quickly. But the telescope is really nice for this because you can have it set up and running in 5 minutes, and it was really fun. So we were really creating something, and it grew bigger, and now a lot of this is automatized, and I don't know how many people are, but yeah, this one has been a part of the Unistellar Brothers Citizen Science campaign, and and which have seen tremendous success. And I think, I don't know, I mean, but thousands of EV scopes are in use around the world by a vibrant community, and over 100 or maybe 200 highly engaged citizen astronomers. And these campaigns have not only collected invaluable data, but have really foster a strong sense of community among us. And this is really incredibly rewarding to be part of a network where both amateur and professional astronomers are eager to share their knowledge and learn from one another. So, of course, the more I learned through these experiences, and the more my curiosity grew, as always. And so there's this desire to understand more about the universe, and also share these discoveries is what drives me and many others in the community. I mean, we think we are really like-minded about this, and we are constantly learning from each other and pushing the boundaries of what can be achieved through citizen science. There is a lot of things happening every year, new steps, new possibilities, new communities. And along my work with Unistellar, I also became involved in a fascinating Zooniverse campaign. So Zooniverse is a website where you can sign in and participate in the citizen science campaign. And I joined the campaign called Planet Patrol. And this project focuses on setting on vetting candidate exoplanets detected by the NASA TESS mission. Um, and I started with online classification, and I was soon invited to join a more an advanced user group. And again, this is where I met extraordinary professional scientists who are just as passionate about sharing their knowledge as the unicellular team. And professional like Veselin Kostov, I honor him so much, and Luca Cacciaporti, Christian Maggiano, and they taught us to the meticulous process of vetting exoplanet transit signals. And this is something we in the group, about a dozen of people, we are all subject matter experts at the moment, and Sovan is part of us. Um, and yeah, working with like-minded citizen scientists, where we've been collaborating for nearly 4 years now already, and our team efforts have led to the publication of 3 research papers, including 2 major works on uniform vetting of 1,000 exoplanet candidates, known as the TESS 999 catalogs. You can Google this. Let me show an example here. So you can find it on Archive already. So the TESS 999 catalog, uniformly vetted candidates, was a lot of work for all of us, and very, very rewarding. And we learned so much with professional astrophysicists with us. So we are gathering every Friday, for 2 hours, and this was really, really nice. Um, and so, of course, this experience, it not only deepened my knowledge in astrophysics, but it sparked turning points in my career. And because of my desire to understand and manipulate the data myself. We had the astrophysicists working with all the raw data, pass them through pipelines to create the graph and displays and board we were using to actually vet. But I wanted to pass from end user to someone who is able to deal with these tools, deal with the data, create the tools we need to work. And so I decided to pivot professionally. So it took a bit of courage, but I left my previous job to learn web development and then data science. And now I'm fully exploring generative AI, um, but always trying back to my passion for astronomy. Um, this is where this journey into the web development and data science led me to create something that I believe is my contribution to our community. It's the Fast Light Curve Inspector, or FLY. We can call it FLY. Something that I initially developed as a simple light curve visualizer to help us analyze the data from the test mission. We needed to look at the light curves and play with them and zooming and pan and do a lot of stuff to actually detect events or non-events. And so I created for myself, and then my colleague encouraged me to enhance it further and to share it. So Fly was born from this collaboration, meeting these people. And it's a free application that allows anyone, and regardless of their coding skills to explore and analyze astronomical data. Because the tool we were using, you had to know how to run a Jupyter notebook, and you have to know a bit of Python, and there are a lot of people that are citizen scientists that cannot deal with these things, and so making an online on the web accessible tool is, yeah, it helps. It fulfills my desire to share my learnings with as wide an audience as possible. And now I will show you a quick demo about the Fast Light Curve Inspector, and you can try out by yourself, of course, because it's openly accessible on the web. Let's see. Okay. Good. Okay. So it is very simple. So you enter the tick number. Tick number is a test inputs catalog number. So I have here an example. Hit enter, and you can see the light curves. So here are the days of observation. Here is the normalized flux, so the brightness of the star. And here, maybe some of you have an idea of what it is. So we see that the lights deeper here and another one here. It's actually an eclipsing binary stars. A fast light curve, the fly will firstly load the data from the QLP pipeline. QLP is a pipeline that creates the most available light curves at the moment. There are other pipelines. If you hit find additional light curves, it will load pipelines Spock, Eleanor Light, and TIS Spock. And of course, you can then zoom on it, pan, so it really allows you to go in detail of this data. You can also, here we only have one sector available, but you could have 10 or 3 sectors available. So if you want to only look at very specific sector, you can hit this. And I have added a few other tools. We can load the background and centroids, for example. These are tools we are actually using in Planet Patrol to vet these candidates and see maybe if there is something wrong with the background. Sometimes the satellites just moved a bit, or there are so many artifacts that can happen. And those are actually really the plots we are using to do the job. And here is the background. Of course, you can collapse the different panel if you don't want to see them. And there is also the phase fold analysis, which is really important. So here, maybe you have a very raw signal and you want to detect, or you think there is an exoplanet transit somewhere, a signal you want to check. So you can hit enter the period days and maybe go this way. Just click on the panel, and it will autocomplete the fields, and you can create the phase fold. And here we can see the phase folding of the primary transits of these binary stars. Of course, there is another way to do it. You could select different position and see how it goes. And here is a periodogram analysis. There is a Lamskagel periodogram. You can generate these for the different pipelines. Okay, so if you're working on the Spock here, it's maybe better to select the Spock as well here and create the Lomscargill. I hope. Okay, yes, it's creating, and we can set the power. And more important here is the BLS periodogram. That's particularly useful for where we can see, okay, there is a strong signal here for 1.822 days period. So if I set it, it's updated the period here for the facefold analysis. I can generate the facefold once more and see something that's really nice. So we have here the primary transit and the secondary transit. So this is where the tiny stars just hide up behind the main star. But sometimes it doesn't look like this. So this is a very nice and clean examples, and sometimes you really have a lot of mess in the data, and it takes sometimes to detect the right period. So this tool is online, accessible with fastlightcurveinspector.app. There is a lot of work on my side left to do. I want to add different tools like a photometric analysis, at least, and maybe some custom modules that I could grab. There are a lot of scientists that create tools that you can run on your notebook, but I like to integrate them and put them there so anyone can use it without coding. And there might be a few issues if you hit a target for which there are maybe more than 15 sectors available. What's happening is the fly is actually downloading all the data from the masts. So it's a big repository with all the public available data from test mission. And so one sector can be 20, 30, 40, 60 megabytes to download. So if you have to do this for 15, 20, or even more, 30 sectors, it can take a while before you can see something, and maybe it may crash at some points. So this is why I need to work on the background and add a more asynchronous way to download all the data. But here it is fast again, because every panel you see, the data is created on the server side. So I could make it the other way around. So let your computer and your web application do all the work. But I know with working with a lot of citizen scientists that not everyone has good computers that able to load a lot of data with a lot of RAM and a lot of CPU. And this is why I designed Fly to create these graphs on the server side. So it makes it, we are all equal this way with using this tool. And of course, if you have a feature request or bug report, you can try here, or you can contact me directly here. I'm using the Lightcurve and Plotly libraries, so only open source libraries to achieve this. And well, I hope you'll have fun to work with Fly. just have a look, have a try to it if you're keen to. And let's move on the next section of my presentation. Because at Planet Patrol, so we've been working with vetting exoplanet transit signals for a few years, and now we've moved into a new campaign about the eclipsing binary. And so the test satellites takes, it's monitoring the brightness of millions of stars across the Milky Way. And among these stars, many are binary systems. And those are systems where two stars orbit each other. And from our perspective here on Earth, these binary stars sometimes align in such a way that they are periodically eclipsing each other. And this phenomenon appears to us as a dip in the brightness. So you've seen these dips. There is a deeper dip and a smaller dip previously on flying. This is exactly what we can detect. And observing these eclipses is crucial because they allow to measure essential characteristic of the stars, such as their size, mass, of course, and brightness, temperature, and all. And what we want to achieve in the end is finding exoplanets around these stars. But first, the challenge is really to first be sure to observe eclipsing binary star. So accurately identifying these binary system can be challenging. And of course, we have automated systems, but and they have already detected hundreds of thousands of potential eclipsing binaries, but they are not foolproof, And there are sometimes where they can misinterpret the signals or get confused about the source, or incorrectly identify solitary stars as binaries, because there is a lot of things mixing up in the way with the instruments we use, or astrophysic events that could lead us to think this is an eclipsing binary, but it is not. Or maybe the star we think is a binary is not, but there is another star so close to it that we thought the signal was from the first star, but it's from another star. And this is very often the case. And this is where our eclipsing binary patrol campaign comes into play. Let me show you. I'm having trouble to share it. Just wait a minute. Okay. Oh, nice. Here we go. So this is really a glimpse into this campaign. So as a community, we will we want the community to meticulously scrutinize the test data and one target at a time. And our goal is clear. We want to confirm the nature of each candidate as a true eclipsing binary, and to ensure the accuracy of their orbital details, periods, and to verify the correct identification of the source star. And once we have established these binaries, our next challenge is to detect exoplanets orbiting these stars, of course. And this task is particularly difficult due to the complexities of the free body systems. So maybe some of you have heard about it. But when we have a single star and a planet orbiting it, it's very stable. It's so maybe Qatar 1b orbits its sun, its stars every 1.4 days, if I remember well, and it's always the case since we've been observing it. It's really time restrained. But around two stars, there are so many things happening that maybe we can see the planet um, eclipsing once, and we have to wait 500 days before it happen again. Even though the planet revolves around its star, orbits around its star every 80 days, maybe, so it's really hard, and this is why we have to take eclipsing binaries, be sure it is eclipsing binaries, and then we will select the best ones that offer the best chance to further detection of exoplanetary corps. So this campaign is not ready yet. In fact, we are still in the process of the review from the Zoniverse team, but we hope it will be available beginning of July this year. And the reason is we still have to generate all the data to get, because we want between 50 to 70,000 targets to be classified, and we have like 400,000 to come. Yes. So you'll find details about what are eclipsing binary, some external project link with the NASA test, of course, a fast light curve inspector, so that would be useful to use during the campaign. And let's have a look at what we will ask you for. So we have 3 panels here, and the question displaying here, and we want to tell if it's an eclipsing binary. So of course there is a tutorial which you should do first, unless you already a Planet Patrol member. So we explain everything and anything about these graphs and what can happen. So here I know this is a clear eclipsing binary because I see a primary signal that is really enclosed in this green line, and there is a secondary here. Okay, and I see the period is right as well, but let's first answer yes, put next. And the lower left panel, is the period correct? And sometimes when the algorithm are messing, maybe they are counting the period between this one and this one, and it say there is maybe a period of 70 days, and you clearly see that we missed a peak between them. I will show you in the field guide what it is like. And here we can see, okay, this is a binary and the period is good. So yes, the period is right. And do you see secondary eclipses? Yes, I see the primary, I see the secondary. So next, and lower right, here is our centroid analysis, the source analysis. This is where we want to make sure that that image is useful and is good for a centroid analysis. And so to be able to tell if the star, if the detected transit really comes from the target we think it is coming from, because TESS is a satellite with 4 different cameras, but they are maybe like the mirror is 10 centimeters. It's really it's small. It's a small instrument, and it means that really often, if you see the images taken from tests in one single pixel, there might be multiple stars, and this is where it is hard to distinguish within this single pixel if this transit comes from the star we know. And we can check this because we have other satellites and other um, instruments with a better resolution, and we know that there are 5 stars, and maybe there is even one that is brighter than the one we want to target, and it's messing because it's contaminating everything. So this is part of the job of vetting. And here, so do you see a well-defined and pixelated bright spot on otherwise dark background? So we really see we want to have a very clearly bright spot, and the rest should be dark background. And sometimes it is not the case. And when it is not the case, the algorithms are really messing around. They don't know. Everything they produce is really biased. So here it is good, and we can pass on. And let's use the field guide, and we can see here a G9 eclipsing binary candidate star with the primary, secondary, primary, and we know we are measuring the right period because the green line is between the two principal peaks. And this is not an eclipsing binary. This is absolutely nothing. This is only, I don't know. There are some times where the algorithm thinks it's speaking something, but there is nothing to see. Here, there is a period off by integer. You clearly see here a primary, another primary, and another primary, but the green lines are picking the period between this one and this one. So we are off by an integer 2 times. So the right period is half of this one. And this is the kind of things we will need the user to detect and to signal. And here is an example of a poorly defined. So see, this is a good example, and this is the worst. We cannot do anything with this kind of images. So once we will have people classified all these tens of thousands of label of data, we will use these labels to train further and to upgrade our machine learning and deep learning system that we are still working on. And because we hope to be able to automatize this job maybe in the next year, in the next coming year. And I'll be working on this on my side as well. So here is what I wanted to show you about this exciting campaign, and just have a look maybe around end of June, beginning of July, and to see if it's live. I hope so. I hope so. So there is 10 minutes left, and I wanted to say something about how to get involved and engaging in citizen science. And so I think it all begins with a spark of curiosity about the world around us. I mean, and we are very fortunate to live in an age where the internet offers endless opportunities to learn about virtually any subject. And I started with a strong passion from my childhood, and but the first time I participated a citizen science campaign was on the universe. It was an archaeology campaign, and then I did the biology with trying to detecting chimpanzee in the jungle. And yeah, I mean it was really interesting to get into it and know, and then you have to you want to know more. And then I took the astronomy, of course, and I am particularly passionate about encouraging young people and teenager to engage with science. And currently I think it feels like the tools and web application we develop for citizen science campaigns are still more tailored for the people of my generation than for the younger. It is my feeling, okay, at least. And however, I think I dream of a day when these initiatives will meet young people where they spend their time now, on their favorite platform. So imagine a future where citizen science campaigns are really integrated into those platforms. The young people use every day, and presented in the way that feels like a game that they would love to play. So gamification is very, very important in the field. And I think this approach would not only make the science accessible, but also even more fun and allowing other young generation participants to learn and share their discoveries in a way that resonates with them and their own uh, way to do it, communicate between them. So I would encourage everyone to give it a try. There is a sci-fi starter, but I know the universe the most. Connect, find something that resonates with you, and start some classification. And who knows, maybe you you will grow in a way you don't you didn't think about it yet, and it will, for sure, you will learn something. And again, this is all about your passion and your curiosity about the world around you. And so, yes, this is my piece of advice. Start where you are with what you like. I mean, the choice is for you. And with the web and all this platform, we have everything we need to start and to be engaged in whatever campaign you want. And this is not about being skilled or scientist or having a PhD. Really, anyone can start. It is designed this way. So thank you very much. I don't know if one of you have any question. I'd be glad to answer. I'm just checking the chat. I don't see any questions. We have 5 minutes left here. So does anyone have any question or would like to see something else? Oh, I could share some images from the UV scope I took. Uh, why not? Why not? So this was a comet Neowise in July 2020, and this was the first one I already took a photograph of a comet with the UV scope. So this is a mosaic, of course. This is a mosaic, and this is of course the Great Orion Nebula, um, and this is a very very nice galaxy. I think it was a Needle galaxy or the other one, 18. I don't remember. Thank you. And M8, the Lagoon Nebula, and I mean you see this is kind of images you can have with the Eviscope. How I prepare data scientists. Oh, let's see you how I prepare data scientists provide piece of advice. And what should be the roadmap for an AI developer to work in the field of astronomy? Mm, for myself, I've been really lucky to be able to join a bootcamp, a data science bootcamp. That helps, but also already working. Thank you, Mario, NGC 891. I was really lucky to actually work with scientists, and they were already doing machine learning stuff. So maybe you can reach me out on LinkedIn, and I would give you some advice. I know of a few online and free content course and lesson you could start with, um, and start your journey into AI for astronomy. Um, Another question: fits files of exoplanets in circumstellar orbits. The fits. You mean the fits from the tests? I think all the data are available on MAST, but some of the data has already been processed with pipelines. So if you're really looking for the raw fits files from tests, actually I don't know exactly where to find them because I never used them. But I would search in the mast at first. So Lygon Nebula. Oh, and sure. This was another comet I took. It was passing by a global cluster, and I was really lucky. I think that day I wasn't even. I didn't know this would happen. You know, I just there it was raining during the day, and just before I got to sleep, I saw the sky that was cleared, and I told myself, oh, let's take the Eviscope outside and see what's what's to see. And so I set it up. I checked the web and see, oh, there is a comet passing by, and just I pointed it, and here is the very raw. I mean, this is really the images. You can see from the Eviscope. There is nothing, no treatment applied. Yes, Uma, the masts. So it's really big website with a lot of data. Um, so it's a Mikulski archive for space telescope. Okay, and here is a link to it. And this was a very famous Dumbbell Nebula. You see, it only takes 4 minutes to actually see, and you can even in 2 minutes you can see this, and in the center you can see the dead star that is blue here, but it's really hot. You're welcome. And the Omega Nebula, and I took these pictures from my backyard garden in the city in Lausanne. So with city sky, city polluted sky, and it would be even better from different. Oh no! I am lying. I'm lying. This is not my location now. I don't remember where I was, but I am lying. Sorry. This is not from a city. This one. And you could have checked, with Google Map. Anyway, I stop sharing, and so we are done for the webinar. At least I can still answer a few questions if you want. You can reach me out on LinkedIn if you have questions about AI, machine learning, our ongoing projects. I'll be really happy to answer. And many thanks to Sovan to organize everything with Hexstar Universe. Thanks for the invitation. I'm really glad to be here and to share my passion with everyone. Thank you.
Thank you, Julian, for this wonderful presentation. And thank you to everybody else for taking the time and joining. Good night, everyone.
Bye bye.
Bye bye.